Good morning, everyone. Welcome to another lecture in platform technologies. So, in today's lecture, we are going to be focusing on file systems. So, when we think about computers and computers in the context of building platforms, building interconnected computers, and so on, one of the things that we will be looking at is the ability to store information for a long time and then accessing them in various means. So that is where file systems come into play, and that's the topic area that we are going to be focusing today. So when we think about any sort of computing system, one of the things that we have to remember is any processing that happens in the computer, they rely on the processor and the main memory. Largely, those are the main two components that are needed to do the computation or the processing task. So, for the actual core part of the computing, we don't need any other components. I mean, like we need number of components to support that, but that's the main memory is like the place that we need relevant to storage of information. But in a sort of a broader computing context, there are a number of reasons why we may want to store and use information at different points in time. And we would need some form of long-term storage mechanism. So, to handle this purpose. So, there are a number of reasons why we may want this. First one is, even when you think about your own computers, you may understand some of these concepts, that the main memory in the computer is normally much smaller than what you would need. Say, on a typical laptop, for example, you may have, say, 4 GBs of RAM or 8 GBs of RAM. So that is like the normal storage capacity that you may have. Even on a very high-end PC, it is not that common to have more than 32 GBs of RAM, even in the very high-end versions of computers that we may have today. So, but when you think about the amount of data that you may have, amount of information that you may want to store, even as an individual, that would be much larger. If you think about how many GBs of files that you have on a computer, you would have much more than that. So, one reason is that our memory is much more smaller. But also, the technology, the way the main memories are built, is that they are not permanent storage mechanisms. They are volatile storages. That is, when we switch off the computer or when a process is terminated, there's no longer, that information is no longer retained in the main memory. So main memory is like a temporary memory that we would use mainly for the processing time. And another reason that why we may want some other type of storage is, when main memory is used, it is normally allocated for a particular process only. So once it is allocated to a particular process, it cannot be used, or the information in that space cannot be accessed by other processes, at least in sort of normal circumstances. So, in typical computing applications, we will come across of a number of situations where we may want to share this information across different processes. So, we may want to, for example, one process may generate some information and then the other process may print that information or then send that information to another party. So, we may have certain processes designed in that manner, and this may even more true in when we build sort of larger interconnected systems. Multiple people may want to access the same information. For example, if we take a web server, the web page that you may be accessing may also need to be accessed by different users. So, in such cases, we may want that information to be shared among multiple processes. So, again, that is not something feasible with main memory or without having a long-term storage mechanism. Then from that set of needs, we can identify three essential requirements that we would want to have from any long-term storage mechanism or technology. So first one is it should be able to store large amount of information. So that is one of the things that we wanted. We would want to store large amount of information in such a storage mechanism. Then that the information that is stored there should be retained even beyond the process life, or when the process is closed, terminated, even after that the information should be retained. More so, even after the computer is powered off, for example, it should still survive. The information should survive even beyond that point. So that is again the non-volatility aspect of storage. Then the third requirement is multiple processes should be able to access the same information. So the information should be shareable across multiple users or multiple processes. So these are the three main requirements we would look at when we are trying to identify a technology or a mechanism for long-term storage. So when we think about long-term storage, we can sort of look back at the history and identify a number of variety of technologies. So it is not from a history perspective we are looking at here. Even from a technological perspective, we can see a number of things have changed over time. So if we think even further and further back in the history, we can even start from older time periods where punch cards were used in certain computing applications. So it started with, say, in the 1700s, it started as a technology used in, say, textile looms, but then it became a technology or an application of that got used in computation or largely sort of calculation counting machines, and then over time we have so those are sort of the very primitive type of storages, but then punch cards were being used till 60s and early 70s, so it's one of those technologies that lasted much longer than any other. But then from the 40s and 50s onward, we started having a number of varieties of electronic and electrical based storages, and then over time we have gone through tape based drives, magnetic hard drives, a number of optical storage mediums, and then we are currently one of the sort of prominent storage mechanisms are based around flash drives and SSDs. Those are some of the current technologies that we are looking at. But also when we think about storage mechanisms, cloud storage is also one of those things that we are dealing with a lot these days. We may be covering that topic area at a later part in this course, but the main thing to understand is the technologies have evolved over time significantly, but that doesn't mean that we are sticking to the latest all the time. Say even now, say SSDs are preferred in many applications, but there's a lot of situations where we still use magnetic storage mediums. The reason being, older technologies can be cheaper, so in certain large scale applications we would still use some older technologies. For example, there's still quite a bit of tape based storage that is being used, particularly in large scale data capturing, particularly in scientific applications. One of the good examples is this like CERN in Netherlands, where they have this like atomic experiments happening, where they collect a large amount of data, and for them to store them, they need some comparatively cheaper technology where it can store a large amount of information, and they have chosen in certain situation to use magnetic tape based technology. So those are like 60s technologies still being used. So that is the thing to remember, is like, so there will be uh, latest technologies, there will be newer technologies that would be preferred, but when we are building larger systems, larger platforms of services and computing systems, we may use a variety of combination of technologies based on a number of reasons. So when we think about a storage medium, a storage mechanism, we can identify two main things that we would expect that storage medium to support. So that is, we should be able to write some information, and then we should be able to read that information back. So that is the fundamental operations or functions storage technology, storage medium should support. So reading information and writing information. And but so that is the basic thing. But when we think about larger storage system, we may want to have a number of other things addressed as well. So things like, how do we find the information? Say, writing a file on a disk is something. So you go and write the information as bits and so on. So that is something. So you have the storage medium, and then you go and store the information there. But now, if the information is stored in a particular place, we should have a mechanism to go to that particular place and finding that information back. So how do we find where a particular information is, so whether it is here or whether it is there? So knowing where the information is, that is one thing that we would want to know. Then in certain cases, what we may have is, within the same storage medium, we may have information that belongs to a number of different users or processors. So in such situations, what we may need to do is, we may need to protect that information between the users. So we have to have certain mechanisms to safeguard or protect or limit access to those information from one user to the other. So again, that is something else that we would want to have in this storage mechanism. And also, then say for example, once we keep on storing this information, and then we get another new piece of data that comes along to be stored, we need to know which of these spaces are free. So we need to know which are free and which are being used, so we can store it in some place that is free and not overwrite some other places that are not free. So again, another thing that we would want to have is identifying which blocks or which parts of the storage medium are freely available. So with that understanding in mind, in terms of what do we want from a storage medium, a long-term storage technology, we can go into looking at what are file systems. So before thinking about what are file systems, the first thing we need to understand is what are files. So basically, files are the units of information that we create from processes. So it is basically, say, if we have some data, a set of information, and then like say any sort of type of data, if we can take that as a unit, and then we can say that is a file. So even in any sort of example that you may come across, say you are creating a document, that the collection of that text you would call as a assignment. So then that is a file. It is just a set of text data, but that particular collection of text data has a meaning. So that logical grouping of that text set of data we can call a file, a particular assignment file or presentation file or something like that. And from the perspective of processes, processes can read these files and they can also create these files. So they will deal with information, or they will deal with data in the unit of files. They are going to read files and they are going to write files. And in any computing system, the files are going to be managed by the operating system. So the operating system is going to have a component that is going to be responsible for creating files and managing files. All the functions related to creating and managing files are going to be handled by the operating system. And the operating system component that is responsible to deal with these files is what we identify as a file system. So files are the unit of information that we will create and use in processes, and the operating system component that is going to deal with that management of files, creations of files and so on is what we identify as a file system. And with any file system component of the operating system, it would implement a number of things. The main functionalities it would do, we can categorize them as sort of key functionalities as these. First, it would implement the concept of a file. So the unit of file, the storage information as file. So that is the first thing the file system would do. Then in most file system, they would also support what is called directories or folders. So these are again logical organizations to have structures within storage mediums. So when we think about a directory or a folder, it is not a physical organization of data. So say when we have again a storage medium, and say we have a number of files here, 1, 2, 3, 4, 5, 6, 7, 8. Say we have 8 files here, and in the storage medium, we will store them continuously like this. So they are stored one after the other in the available space of the storage medium. But in an organization within the computer, it can be presented in a different structure. So what we can have is, we can say, for example, these 3 can be in a directory, in a single directory together. But then it is also possible for us to have 4, 6 and 8 in a single directory. And then maybe having 5 and 7 in a different directory. So the organization within, the logical organization within the computer that is normally presented to the users doesn't have to be the same as how it is physically stored in the storage medium. So that organization will also be handled by the file system of the operating system. Then they are the ones also responsible for implementing the security requirement that we would have in file systems, in computers. So limiting access to users, limiting access to processes, who can create, who can edit, who can manage these files will be controlled by the file system. But at the same time, while limiting access to these resources, they would also in a controlled manner allow access to certain users or certain processes. So this is where we may do sharing. So security is limiting access to who can read or write, but then again we may permit some people to say they can read or write. So that is sharing between different users. So these are the main sort of 4 things a file system may be implementing as sort of conceptually it may be implemented. The implementation may differ from different file systems, and we can briefly touch upon that at the later part of the lesson. But the main thing is these are the things we would expect from a file system. So now let's start looking at each of those components. First one is files. So files are, as we said, they are the basic unit of information, and they are the ones that are going to hold the data from users or processes. And in addition to that data, they will also have some properties or some information about those units of information. So these are things like we can have like file size information, file ownership information, time related information as to when a file was created or written. Then in terms of protection information about who has access, who can read, who can write. So these are things, for example, you can see even on a Windows computer, you right click and go to file properties, you may see some additional information. So that properties is information that is not the core information of the file. So say if you are creating an assignment, the document itself is the main information there that is stored there. But in addition to that data, we will also have some other properties about that data. So that will be also part of the file. And in many file systems, we would also support what is called a file type. So essentially, for a computer's perspective, there's no need to have explicitly identifiable file types, because it is any process will open a file and then it can read from the bits from start to end, and then it can process it in any manner. But for certain ease of management, ease of use, and even from a computational point of view, we may have what is called these file types. So we can have things like different file types like executable files or exe files for applications. We may have other file types for different things. Then we may also have what is called the special file types. We will discuss about this a little bit later. So these are file types that are mostly used by system. So there will be some file types that are used by the operating system, but you may see them. Say you can see a DLL file or an exe file, you can see in a directory. But then underlyingly, there may be other system files such as directories or what we call as character files, block files to map different drives and devices. These are things that you are not going to see as a file from a user's perspective, but underlyingly operating system may use these as files. So they are not for the users, they are for the operating system itself. Then when we think about the files that we would interact on a regular basis, like the normal files, we may again have a number of file types. So normally these are denoted by file extensions or like file name extensions like text files, doc files, PPT files, and so on. So and sometimes we can differentiate a doc file is a document, a JPEG file is an image file. So we can differentiate between file types based on these file names as well. So in terms of file naming, we can have, say, in addition to the file name, we will also have an extension, and the extension can specify what the type of file is. So in certain examples, like a PDF can be, it is called a portable document format, or a text file, or a zip file. So the extension itself would specify what the file type is. Then in addition to the file types, we may also have a number of attributes attached to these files. So these are the properties of files. So things like protection to say who has access to the files. Certain at times we may have a password with the file, then information like who created or who is the owner of the file, or time related information, size related information. So there are a number of things that we can have, even things like whether it is a read only file or a hidden file. So number of these properties we can also associate them with a particular file. Then when we consider particular types of files in terms of the internal structure about how the data is stored inside that file, again we can have a number of categories. So the first one is basically a file where from starting to end it is storing one byte after the other. So it is a continuous set of a sequence of bytes where the information is stored. So the operating system can just go and read from start to end and it will understand the file. Then we may have certain other files that are of a different type where they have a set length of records repeating one after the other. So say we may have a file where it has 32 bytes of records repeating one after the other. This may not be something that you may come across a lot these days, but these are certain files from a legacy perspective. There were certain situations where these were used, and even there may be certain applications where this could be used today. And the third category of files are what we identify as a tree of records. So we would start with a set of records and then again they would point to further set of records and so on. These are sort of hierarchical structure of data. So again, you may come across these in certain large mainframe computer environments, but when we think about typical computing that we may do these days, even in sort of large scale environments, these sequential files are the most common type of file that you may encounter. So now when we look at different file types, we can again categorize them as based on what they do. So this is what we earlier sort of looked at briefly. So that is regular files are the normal files that users are going to store information. So these are your documents, images, videos and so on. So they are regular files. Then beyond that, underlyingly, the operating system itself is going to use certain files to have the information about directories. So directories or folders in an operating system are essentially files that have the information about a directory. So when we say a directory called documents, it is basically saying a list of files, say these are the files that are stored inside the directory. Then the operating system will go and read this directory file and identify what are the specific files that it needs to display when you open the directory. So when you double click and open a directory, for example, in an operating system, it may go into reading this file. The operating system will read that file, that directory file, and then show you the file system structure. So these files are not normally displayed to the end user. So if you are interacting with the operating system, you may not see these things as files, but underlyingly they may be treated as files. Then in addition to that, we may have two other types of files called character special files and block special files. These are normally used to map out certain input-output devices or even storage devices. So certain printers and certain storage mediums, they may be mapped as files inside the operating system. And then say, for example, if you want to print something, you go and edit a particular file or add some information onto a file, and whatever information you save in that file will get printed. So the printer will always try to read that file. When there's new information in that file, it will take that and print. So that is a way this type of a character special file can be used from a hardware interaction with input-output devices. And even inside regular files, we can further categorize them as ASCII files or text files and binary files. So ASCII files or text files are things that you can read the content and understand to some extent. So say for example, if you right click a text file and open it on a notepad, you can read the text. Even if you right click an HTML file and open it on a notepad, you can still read it. But if you right click a JPEG file, an image file, and open it on notepad, you may see some text, but you cannot meaningfully understand that. You have to have a separate program to understand or interpret that information. So those type of files, the internal structure of the file needs a program to understand, are what we would call as binary files. And if we can understand the content textually, we would call them as ASCII files. Then in addition to that, we may also come across what are known as executable files. So these are your exe files when you have programs. So they may have certain additional information about structure, internal structure of how they are organized. And then we can have archive or compressed, doesn't have to be compressed, but archive files like a zip file, where it is going to have internally a number of files stored together. So these are also some other additional type of files we may come across. Again, these are still going to be regular type of files within an operating system. So these are the main 4 categories of files, and inside those 4 categories of files, we can take the regular files, and they can fall into a number of categories, number of subcategories. So once we have these files in a storage, we have this concept of files now, and we also have the concept of directories and so on. And with some properties of files, we can also specify who has access, and all those things are there. But now, when we think about actively using these files, we have to think about how these files can be accessed, how these files can be read and written. So that would depend on different file systems and different underlying technologies in terms of how we can go about reading and writing files. Again, here we will categorize them in 2 separate categories. One we call as sequential access, the other one is random access. So when we say sequential access, if we have a storage medium like this, then in a sequential access, what we have to do is we have to start from the beginning, and we have to go one after the other and read the whole of the storage, or go through the storage in a start from end order, and then we have to read it like that. Say if we want to read the information here, we have to start from here and go there and then read. So that is sequential access. So the records of files are traversed from starting to be ending in an orderly manner. So that is sequential access, and these are normally what would happen in magnetic tape. So if we store some information in a magnetic tape, you have to start from the beginning of the tape and play the tape and go to the part where the file is, and then you can read it. So the tape has to rotate and move it to the particular position where a particular file is located. When we think about random access, here the difference is the technology here we would have, it can directly go and read that information. So in random access, what we would have is, if we want to read this file, we can go there and read. Then if you want to read here, we can directly go here and read. We don't have to wait or to go through all these things. So we don't have to do that. We can directly move to the point. So this is what we would use in most disk-based storages. This is what we could do. We can go and directly read a particular file. And this type of random access is something that would be needed in many applications. So if you want to quickly read some information and any part of the information should be readily available, we should be able to quickly access a particular part of the information. So in such situations, we would prefer to use random access based file systems. And then we can look at what are some of the common operations we would expect the file system to support. So we identified reading and writing as the main sort of things that a file system should do. But when we think about typical files that we may come across, we may need the file system to support a number of other operations as well, because the underlying file system of the operating system is going to give these functions to any application software to use. So for example, if you are using a document editing software, that document editing software is going to get these functions from the operating system to access the storage media. So these are some of the functions such a application may need. So things like creating a file, deleting files, opening files, reading and writing files, and sometimes even adding additional information, appending to files, renaming files. So these are again typical operations that you would be familiar with in any file system that you may have used. So these are some of the things that we would expect these file systems to support. So are there any questions on things that we have covered so far about files and file systems?
No, sir.
So let's continue our discussion into directories. So files, then the next type of files or next main thing that we would have in a file system is a way to organize these files, and that is what we have as directories. So one of the main purposes of having directories is it gives a structured way to organize files for users. So for example, if you think about your computer, there may be like thousands of files in your computer. And if all those 1,000 files are just placed in the same location, in the same drive, without any structures of directories, it would be very impractical for you to traverse and get access to those files and so on. So even from a human perspective, from a user perspective, we expect some order. Say for example, you may want to store our music file separately from movies and our work documents separately. Then even when you think about your study materials, you may store them in different directories for different subjects. So this is a way of organizing these things, and we may want to do the same thing in file systems. And it may also give certain information or certain way of organizing and separating things for the operating system as well. Say having programs in one directory and having certain libraries in a separate directory and so on can be useful way for different programs to access the same things in a sort of more convenient manner. So that may also be a reason why we would want to have these directories. And most file systems will also support multiple levels of directories. So it is not just one layer of directories that we will have like hierarchical layer of directories. Again, these are things that you would be very familiar with from your day-to-day use of computers. And instead of most computers, we could also have these additional concepts of identifying a path in a directory. Say we could say that is C, program files, then say for example Microsoft, and then Word or Office, for example. So then we can have this as a path or relative path to a particular directory. So again, that is also some, like as a naming convention, we could say, we would be able to say this path into the hierarchical path into the directory as part of the file name, or like as to identify a particular file. So again, these are some of the features that we may find in file systems relevant to directories. So as I mentioned earlier, directories are going to be internally mapped as files in most file systems. So what we would have as a directory is just a list of entries, and that list of entries is going to identify a name, so a file name or even a name of a directory, and a location. And if that location is another directory, then it may point to another directory file, and then that can point to further files down the line. So directories are internally going to be set of entries or list of entries identifying what are their contents and their locations. And the location can be organized in any manner. It can be based on blocks or various things. That is the underlying structure of the file system. But at a directory level, it is going to have this list of names and the locations of those entities. So that is the directory file. So the file that is holding the information, or this pair of information as a list. Then similar to file operations, we can also have a number of operations that can be supported for, particularly for directories. So creating and deleting directories, opening, reading, linking directories like shortcuts or dynamic links and so on. So these are some of the common functions that we may use with directories. Again, these are, when you think about your day-to-day use of computers, these are again some of the things that you may do in those systems. So what we have looked so far in terms of files and file types and directories, these are about the logical organization of the file system, how the file system is represented logically for the view of users and operating system. But then we can also have an underlying physical structure, how the file system is organized, what is the layout of the file system from a physical perspective, how it is actually stored in the storage medium. So here we would use the concept in most cases of blocks. So what we would have is, if we have a storage medium managed by a file system, we would break that into units of blocks, and normally blocks will be a fixed size blocks, and then we would read and write information as these blocks. So instead of reading every bit by bit or byte by byte, we would normally have a slightly larger block of data so that we can read and write information as that unit, because it would be much easier to do it in larger units than going and reading one by one as a byte. And then in a storage medium like that, we would identify, in addition to the actual user storages, we would also identify what is called a master block. So master block will normally be a part of the storage medium, normally at the beginning of the storage medium, that we would use where it stores the information of what we call as a root directory. So root directory is like the thing that can point to other things. So Directories are the things that are going to point to files. So the root directory in a context of Windows is like the C drive. So that has to be located at a starting point or known location, so then it can read other directories. Say you have a hierarchical file system and you have a number of directories and files and so on. So all these things can be stored somewhere, and each of these are going to have a directory file. But for a file system to read, we should be able to identify the first directory. We should be able to identify the root directory. If we read the first one, then we can start reading all the pointers after that. So that root directory should be located in a place that is well known. So normally that will be located at the beginning of the storage medium. So then, in addition to that master block or the root directory, we would also have what is called a free map. So a free map would identify which locations of the directory are free. Say for example, if in this storage medium we have used some of these spaces to store files, so some are used, but then a free map would identify these spaces are freely available and new data can be stored in them. So if a new process needs to store some information, the file system will go and check the free map to identify which are the free spaces, and then it will store the information there. So that free map and the root directory will have to be stored or managed at a fixed location, because those are like system files or system information necessary for the file system. And beyond that, any information that we have can be used to store regular user files. So whatever your documents, images, videos and so on will be stored in this part of the file system. There will be a beginning part of the file system that will be used for this master block, root directory, free map and so on. So in a typical file system, we may have what is called, say, if we take the entire disk as the whole, there we may have a master boot record. So that is when a file system is booting, the BIOS will load this boot record and go to there and load. Then we may have a partition table partitioning a particular disk, and then we may have a number of disk partitions. Then inside a single disk partition, we will have the boot block. So that is where this root directory and those information are going to be stored. Then we may have what is called a super block. So that is maybe for certain file systems it may be there. Certain additional information will be there about the file system. Then a way to manage free spaces. So how do we manage free spaces? So that will be there. Then in certain file systems, we may have what is called inodes. This is a way to manage directories and the information about root directories, and then our regular files and directories. So this is a typical file system organization layout. So this is not how every file system is going to be, but this is like at least some of these things will be there in most file systems. So now when we think about actually storing files in these file systems, we have to think about how we are going to store this information. So we already identified that we are going to break this storage medium into blocks of storage. So not going to store things as continuous allocation, like continuous bits of data, stream of bits. We are going to break them into blocks. So then to store those blocks, when we want to store files as blocks, we may have to store them across multiple disk blocks, because not every file is going to fit into that block size. So we may have to store a number of, we may need a number of blocks to store a single file. So to do that, we can have a number of approaches. So continuous allocation is where we will store information in a continuous manner, one after the other. So what we have in continuous allocation is we start from the beginning of the storage medium. We would store one file, then next another file, one after the other. Whenever files are available, we will store them one after the other. The problem with this approach is, say for example, if we delete file D, this part becomes free. So that is a free block. Those blocks are now free. And if we delete file F now, this part is also free. So now we have a number of these spaces as free spaces. So this part and this part are free spaces that is available to us as free spaces. But when we say now, if you want to store say a 10 block file now, we actually have 10 blocks free. We have actually 11 blocks free. So even though we have 11 free blocks here, we may not be able to store them because we need continuous allocation. We need continuous 11 blocks to store these files. So continuous allocation is an easy approach. It is fairly simple, fairly easy to do. But the problem is it will cause what is called fragmentation. We would need these spaces that are unused. So we need to somehow organize them in a better way to move these files. So that is an easy way, but not an efficient way. The second approach is what we call as a linked list. So here what we have is, we would go to a particular block, we will store the block there. From there we will point to the next block and so on. So we will have different blocks stored one after the other, and then they are going to point to each other as a linked list. So they are linked one to the other as a list. So for example, when we take a file system like this, what we may have is, this block may be stored here, this may be here, this may be here, this may be there, and this may be there. And then what we would have in terms of the links is, they may be pointing like this, and here, and there, and there. So they are going to have pointers from one to the other across this storage medium. So they are not going to be continuous one after the other. They can be stored anywhere. So the physical order doesn't have to be the same as the logical order of the blocks, and they can be in any place. So the advantage with this is, when we want to say the issues that we had with continuous allocation are not here with linked list structure. So it is good when we want to sequentially read a file from beginning to the end. But the problem is, if we want to read the middle part of the file, it could be a problem because, say for example, if we want to read this part of the file, we may not know where that part of the file without reading this pointer. To read that pointer, we have to read this file. So again, here we will end up with a situation where we are doing a sequential access type thing. So we are going to this block, then only we can identify where the next block is. So then we go to the next block, there we identify the block after that. Then only we can go to a particular part of the file. So if we are reading the whole file together, it's okay. If we are reading a file sequentially, it is okay. But if you want to randomly go to a particular part of the file, this may not be a suitable approach. Then another approach that we may have is what is called I nodes or index nodes. So these are basically what we have is, we will have a list of entries, what we call as the I node, and that is basically a set of pointers pointing to different disk blocks. So these pointers are going to point to different disk blocks. So that is the main entry that we will have. Then we can go and read each of the block as we need. So we will read the whole entry together at once, and then we can go to the pointers. So in linked list structure, we have to go to each of the block to identify the next block, whereas here we can go through these entries, the index node entries, and then we can go to the particular address. So if you want to go to block 4, we can go to this entry, identify the address for that block, and directly go there. So this would support, this would be in a way an improvement from a linked list structure. And in certain cases, what we may have is say if we can't store the whole list of entries in a single block, then we may even use multiple blocks here. So there we may point to another disk block and use. So what we have is we have 3 mechanisms here. Continuous allocation, where we are storing blocks one after the other. Linked list structure, we point from one block to the other, and the pointer of that block will be found on the next block. And index structure, we have all the pointers in a single block, so we can easily go to another block. So index structure will be much more suitable for random access as well as sequential access. Linked structure is more suited for sequential access, and continuous allocation is a fast and easy approach, but not suitable, and because it has fragmentation problems. So then one of the other things that we said in terms of files is files can be shared between processes and users by attributes of the files, who is the owner of the file, who has the access to files, and so on. But one of the other possibilities with files is we can share files between directories. So for example, a file is basically a unit of information stored somewhere in the storage medium. And a directory is basically a list of entries having a pointer to the file. So technically, it is possible for us to have that entry, that pointer entry, in different directories. So say we can have like directory B having an entry for a particular file. The same pointer can also exist in the directory B's files list. So now the same file will be present in the 2 directories. So it is a way to share files between directories. It can also be used when we are moving files across directories, or to understand what happens when we are moving files across directories. So here when we move file from one directory to the other, what we need to do is, say if we are moving from B to C, so first we had this entry. So what we do is we go and remove this entry and create a new entry here. So now technically the file is moved. So we don't have to physically change anything in terms of how it is stored in the disk, in the storage medium. We just change the pointers across to a different directory. So that is another thing that we may notice when we are working with directories and files, is because there's no physical relationship with files and directories, we can manipulate these directories in this manner to either share files between directories, or even moving and copying files can be done in a similar manner. And one of the other things that we may come across in many file systems is what we call as file buffer cache. So this is what we mean by that is, we may have an additional storage medium. So if this is the storage, like the actual storage medium, what we may have is we may have another small storage place. Maybe that is faster to access, much closer to the computer, maybe a different storage technology, like this may be slower technology and this may be faster technology. and we would call this as a file buffer cache. So what we do is, when a file is being read from here, we will move the blocks of that file into the main memory if a file is being read. But then what we may also do is, we may also read the subsequent blocks of that file, because we have this property of locality. Say if you start reading a file, you may normally read the rest of the file. If you start playing a music file, for example, if you start playing an audio file, it is fairly okay to expect to load the rest of the file, because you may be playing the rest of the file, because you may continue to play the same file. Or if you read a document, you may continue to read the rest of the document. So it is best to load the rest of the blocks as well. So for that purpose, we may have this intermediary storage place where we may buffer some files and read. And we may also use that from a writing perspective, where our actual storage writing speed may be much slower. So we may write into a faster memory, and then it can take from there and write it into the slower storage medium. So that is what we may call as a file buffer cache, and this may be found in a number of storage mechanisms. Say if you think about a hard disk or an SSD, they may advertise in their specifications as to having a particular size of a file buffer cache, like a 4 MB or 2 MB or something like that is common to be found. And one of the last things that we will have in these file systems, again something that we looked at previously, is about keeping track of the free files or free blocks in the file system. Again, here we can have a number of approaches. Say we can take a number of blocks and use that to store information about the free blocks. So what we would have is, we would have a linked list that is saying what are the free blocks that are there. So it will have a list of entries that are pointing to various free blocks. Another mechanism that we can have for this purpose is what we call a free bitmap. So here we would have a bitmap or set of bits to identify each and every one of the blocks in the storage medium. Say if our storage medium is split into 64 units, here we will have 64 bits. So however the larger the storage medium is, we will have that many number of entries, and there we would have a 1 to say it is free and 0 to say it's being used, or vice versa, 1 to say it's used, 0 to say it is free, but it is a set of bit entries to say whether a block is free or it is used. So when now a file system needs to write a file, it can go and check to see what is the free space, and then it can directly go and write that file. So then we can sort of briefly look at sort of some differences between different file systems. So for example, this is a MS-DOS file systems, or similar known version that you may have come across is FAT32 file system. So this is the structure or the layout of this particular file system. So as we said, there may be certain differences between different file systems. So this is the main structure or the organizational structure for this particular file system. So it may be differing from one to the other. This is the NTFS file system. So again, this has slightly different structure, different ways of how say the master file table, partition table, and those things are organized in slightly different manner compared to the MS-DOS or the FAT32 file system. And another file system that we may come across in sort of Linux operating systems is what an extension for a journaling file system. Again, we are not going to go into specific details of these file systems in this course because that is not the focus here. But if necessary, you may be able to look these things up. Here, journaling file system is an example where we have these indexed entries, where we have these inode index entries that are pointing to different blocks or further pointers to blocks and so on. So these are some of the internal structures, internal architectures that we may find in different file systems. So that's all we have to cover in terms of file system for this course. Some of these things we have covered in a fairly brief manner, but if necessary, you may be able to understand them by a bit of further learning. The main thing to understand is how the file systems are organized, the concept of files, directories, and how those things are interconnected. Because when we build larger systems, when we build larger interconnected computing systems, interchange and exchange of files is going to be a crucial operation. So having a better understanding of the underlying file systems is going to be very important. And as I sort of initially mentioned, one of the things that would be much more relevant to this sort of study area is about cloud storages or network interconnected storage mechanisms, and we may come to discuss them at a later stage if possible, because that is also an important way we can think about storing information for a long-term storage, but in a network connected, interconnected manner. So do you have any questions on the things that we have covered so far in file systems, or any other doubts or clarifications? So if there are none, we may conclude the lesson for the day, and we may continue next week in the same schedule. In the meantime, I may be posting some continuous assessments for you so that we can have those things as well. I will share those information via LMS, and I may also send a message about that. So other than that, we may conclude the lesson for the day. See you next week, and thanks for joining this time. Bye.
Thank you.